In this video, we're going to look at a couple of more trigonometric substitution examples. So here, you look at this and you say, well, it's not a product, so it's not by parts, it's not a fraction, so it's not partial fractions, and substitution isn't going to work because if u was 4 minus x squared, I would need some x out here for substitution. So that takes us to trig substitution. So let me create my little spot over here for a triangle. If I draw this triangle, and I always draw it the same way and put theta in the same spot. Now remember, we're trying to mimic Pythagorean theorem. So in this case, we have a difference. We've got 4 minus x squared. Well, in Pythagorean theorem, when we have subtraction, then we must know the hypotenuse. The hypotenuse must be 2. And then this must be x. And then this is 2 squared minus x squared. So now we've perfectly mimicked Pythagorean theorem with this triangle. Okay, so let's write down what we know. Well, this time with using x and 2, it's going to be the sine of theta is equal to x over 2, opposite over hypotenuse. So that means that x is equal to 2 sine theta. And dx is 2 cosine theta. And theta is the inverse sine of x over 2. Now, if you're thinking to yourself, why couldn't you have put x right here? Would have gotten the same thing. That's a valid point. You absolutely could do that. The most common trig substitutions are tangent, sine, and secant. Those are the ones that are usually looked at, so those are the ones I'm using. I know that through experience that these are the ones we aim for. But you absolutely could have put x down here, and then you would have been, of course, involved in a situation using cosine. It really would not have mattered. Okay. Let's rewrite our integral. So the square root of 4 minus x, which is 2 sine theta squared, times dx, which is 2 cosine theta. I'm going to bring the 2 out front like that. Let's actually then rewrite a little bit. Let's have 4 minus 4 sine squared theta times cosine theta d theta. Let's do a little factoring. So pull a 4 out. Okay. Now, the square root of 4, I could pull out and have another 2 there. So now I've got 4. Now, 1 minus sine squared, this is cosine squared. And the square root of cosine squared is cosine. So we end up with cosine times that cosine theta d theta, which of course is 4 times the integral of cosine squared theta d theta. Okay. Now, using our little trig identities here, put them right up here, I know that cosine squared is equal to 1/2 times 1 plus the cosine of 2x. So, boy, I'm really running short on room. Let me see if I can't fit the rest of this in. The antiderivative of cosine of 2 theta is 1/2 sine of 2 theta. Okay, so I multiply the 2 in from out front, and I have theta plus 2 theta, excuse me, plus sine of 2 theta. Now, I want you to look up here. The sine of 2x, what that's equal to. Okay, I could rewrite this as 2 theta plus 2 sine theta cosine theta plus c. So this is it right here. This is the integral. But I don't want to leave it in terms of x. I want to put it back in terms of theta. So 2 times the inverse sine of x over 2 plus, now, this gets a little tricky because now the sine of theta, well, I know the sine of theta is x over 2. I can look up here and see that, right? Sine theta. The cosine theta I've never had to use, but cosine is adjacent over hypotenuse. So I could replace the cosine with the square root of 4 minus x squared all over 2 plus c. Now, I am completely out of room. I really pushed this. So let me just tell you, the simplifying I would do here, I would, I cancel these 2's out. So then I guess it's not too bad. I would move that x kind of over to be the product, and I'd have x times square root of 4 minus x squared all over 2. So my final answer is 2 inverse sine of x over 2 plus x times square root of 4 minus x squared all over 2 plus c. Okay? This is a pretty intense problem. There's no doubt about it, because at the end you end up with these trig functions that are not immediately easy to go back and substitute. But, we've got 2 times sine theta. We know what sine theta is. And cosine theta we can get because we've made the triangle. Cosine is adjacent over hypotenuse. So it's similar. It starts off similar to all the other trig substitutions, and then we got to use an identity, and then we got to use another identity. So it's an intense problem, there's no doubt, but very doable knowing those identities and having your triangle to substitute in at the end.